welcome to yet another video on our channel Euclid Mathematics. We have started lecture series on MHT CET Mathematics previous year question paper. So within that already explained plenty of the videos on my channel. So most of the videos are there. So if you wanted to see more videos, previous year question paper and along with the concept, you may check it into my playlist. So here in my today's video, I will explain to you all one of the question. So this type of the questions are gives us very easy marks. So we always have to attempt this one first. Now let's get started our today's question. I will explain to you all the question and after of that answer. This is the question. So in question we have given x and y, two values are there, and then we have to find out dy by dx. Okay. So as we observe here, x is given as e raised to theta sine theta minus cos theta. Okay. So x is in the form of a theta and y also it is in the form of a theta, and we want the differentiation of a dy by dx. So try to remember from your differentiation chapter how we can solve this example. So if we have the x and y variable in the form of some other variable like a theta, and then we want the dy by dx, so we have to use a parametric differentiation, which is one of the important topic which every year the question asks for such topics. Okay, so and very easy question, just we have to find out the easy differentiation, and we know that the differentiation of exponential, it is exponential itself, and if you go through the differentiation of a trigonometric, it goes trigonometric, easier quantity there. Okay, so it is quite easy, just we need to know only the parametric differentiation, how we can use it here. Okay, and we want the dy by dx at the theta is given at a pi by 4, so we want the value for theta pi by 4 for our dy by dx. Okay, and options are given a1, b0, c1 by root 2 and d root 2. Okay, now let's see the solution for our example 33. Okay, so it is quite easy solution. Let's get started our today's solution. So here in my solution, we will see first what is mean by parametric differentiation and how one can apply. Okay, so we want the value for dy by dx, and in our example we have given x and y in the form of a theta. Okay, so we have to differentiate them in the form of a theta itself. But parametric differentiation, which says that if you want the dy by dx and differentiation with along with the theta, so we write dy as a dy by d theta and dx as a dx by d theta. Okay, and find out the value for dy by d theta, dx by d theta, and substitute it here, and then you will get the value for dy by dx. Now first of all, our first target is here to find out dy by d theta, and second target is here dx by d theta. Okay, it's just easy differentiation, and after of that at the end we have to put theta as a pi by 4. Okay, so now let's get start first differentiation, which is a dy by d theta. So here in our example we have given x which is equal to e raised to theta sine theta minus cos theta. Okay, so it is easier to differentiate x with respect to theta, as we earlier we saw most of the example which is differentiated with respect to x with respect to y. Okay, similarly we have to follow this procedure here. Instead of x and y we have only theta, and we are differentiating x with respect to theta. So don't get confused, answers are quite easy. Okay, nothing is difficult there, just need to go through the differentiation with respect to theta. Okay, now here in our question x is given e raised to theta sine theta minus cos theta. Okay, now find out dx by d theta. Dx by d theta means we have to differentiate that two different function. Now we can see it here. First function it is the exponential, which is e raised to theta, and second function it is the sine theta minus cos theta, which is the trigonometric. Okay, so apply by part rule of a differentiation. So by part rule of differentiation, it says that if we have two function like integration differentiation of a u into v, so we write the differentiation as first function as it is differentiation of a second function plus second function as it is differentiation of first function. So similarly I did it here, first function as it is differentiation of a second function, differentiation of a sine theta cos theta, and differentiation of a cos theta, which is a negative of sine theta, and negative become positive. So second differentiation it is here. Now second bracket as it is differentiation of first function, and exponential term is always having differentiation exponential term itself. Okay, so here the dx by d theta from our theta x. Okay, so similarly move for the dy by d theta. Okay, so as we have y which is equal to e raised to theta under bracket sine theta plus cos theta. Okay, so this is the value for dx by theta. Our first target is complete here. So have example solved. So last target is here, just we need to find out the value for dy by d theta as we did for dx by d theta. So similarly we have to follow for dy by d theta. Okay, now here y which is equal to e raised to theta under bracket sine theta plus cos theta. Now differentiate y with respect to theta, so dy by d theta, and differentiation here again apply by part rule. Okay, so u into v form is there, exponential into trigonometric. Okay, so when we use by part rule, under differentiation or bipart rule under integration. That time we are having two different rule, ILET rule or ELIATE rule. These are the most important result that we need to know while we are differentiating or integrating by using bipart. Okay, but in our today's example, we do not need these rules here because question it is quite easy. Okay, just this can be solved very easily. Okay, we no need for this type of the rules here, but you need to know these rules because these are very much important when we deal with the difficult type of the bipart rule examples. Okay, so now let's get start for dy by d theta. So y it is here, and then dy by d theta, which is a first function as it is differentiation of a second plus second as it is differentiation of first. Okay, as we did earlier. Okay, so it is quite easy. Exponential theta is having differentiation exponential theta itself, and sine theta having differentiation cos theta, and cos theta which is having negative of sine theta. Okay, so take the e raised to theta common from both of these, we'll land on cos theta minus sine theta and sine theta plus cos theta. Okay, so take this term together, so we can see here negative sine theta, positive sine theta get cancelled, then will remain only cos theta plus cos theta. So 2 times cos theta, and e raised to theta as it is. Okay, so similarly 2 times e raised to theta sine theta here. Okay, so our main task is here to find out dx by d theta and dy by d theta. Okay, so it completed here. Now put these values in a dx by dy by dx. Okay, so dy by dx, which shows that dy by d theta upon dx by d theta. So dy by d theta, it is here 2 e raised to cos theta, 2 e raised to cos theta here. Okay, and dx by d theta 2 e raised to theta sine theta. Okay, so 2 e raised to theta, 2 e raised to theta get cancelled, cos theta upon sine theta, which is cot theta, and we want the dy by dx at the value theta, which is equal to pi by 4. So dy by dx at theta, which is equal to pi by 4, is a dy by dx at a pi by 4. So cot theta at a pi by 4. So cot, put the theta as a pi by 4. So cot pi by 4, we know that it is always 1. Okay, so these are the just basic examples, very easy solution. We'll get that one. Okay, we are getting this one, so nothing is difficult here in our today's solution. Okay, it's one of the quite easy question and along with the solution. Okay, so I hope so you all have understood my today's lecture. Nothing is difficult here. So even after you may have any difficulty or you face any type of the doubts here, so let me know in comment section. I will come up with the more videos on your doubts and in your topic. Okay, so thank you everyone. Thank you for my today's lecture.